All right, so we are now going to be working on 12.5 angle relationships in circles. And again, each of these theorems that we talk about today are going to be provided in your Chapter 12 theorem sheet so that you can reference as we go along and as you work through quizzes or tests. So our first objective today is to find the measure of angles formed by lines that intersect circles. So we've got a lot of lines today going through circles, and then use angle measures to solve problems within those circles. Alrighty. So the first theorem that we're going to talk about today is 11.5.1, and this one talks about if a tangent, so this is the tangent here, and a secant, or a chord if it stopped there. So we're going to fill that in, tangent. And secant. And remember that there is a notes packet that you could be following along with here with all of the blanks in it as well. All right. So if a tangent and a secant or a chord intersect on a circle at the point of tangency, then the measure of the angle that is formed here is half the measure of this intercepted arc. And it's weird because the arc goes right into that angle, but again, whatever the measure of this arc is, half of it is going to be angle ABC. And that is what they're saying here. So an example to look for that, and of course, most of the examples aren't as basic as this guy here. So we just need to be aware that we're looking for a tangent and a secant or a chord. So for instance, when we're finding the measure of EFH, so E to F to H, we're not actually going to use any of this stuff down here. So really, you're just separating to find H to F. And how that reacts with E. And the only number that helps us on that is that this arc right here is 130 degrees. So again, all of these other pieces are not helpful when we're finding EFH. Okay, so EFH is in fact going to be half of 130 because 130 is the arc that's going in there. So we just take 130, divide by 2, and we're going to get 65 degrees. All right. Then taking a look at this next one, now instead of the angle, they want the arc that they're talking about. So we're talking about the arc from G to F. So let's see, G to F. Okay. So one thing that we will note here in the circle where we take out all of the stuff we don't need, which is up here, we have a tangent line that meets at G. And then we have this chord that goes off from G to F. And then instead of telling us anything about this arc or this angle that we're actually interested in, they tell us that this angle is 122. Well, that is actually helpful because in order to get this angle measure, we would take 180 minus 122. And then we get this angle measure here. So that's going to be 58 for just this angle. But of course, we're not interested in the angle. We want the arc. And so in that case, we need to take the angle of 58 and multiply by 2 in order to get 116, which is the arc measure. All right. So in review, to get the angle, you take the arc and divide by 2. But to get the arc, you take the angle and multiply by 2. All righty. So the next theorem, 1152, talks about this circle here that happens to have two chords, or could be secants, that go through, and then we want this angle. And remember that point E is not necessarily the center of the circle. So depending on how you're looking at it, it could be, and it will work if it is the center of the circle. But now that we've moved this dot off of the circle, we don't have as easy access to its angle measure. So we get to do a little bit of this. So for the theorem, if two secants or chords and of course that's what these ones are, intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures. And so when we think of half of the sum, especially since there are only going to be two measures, this is actually kind of like the mean when we're talking about averages. All right. So here we are. It says that measure of AB, meaning this arc measure here, and the measure of CD, if those are known, we can get the angle of 1, or in fact this angle as well, because they're the same from vertical angles, is just going to be half, or the two numbers that you have divided by the number of numbers, or a mean. This one here is has tended to be called the Spider-Man theorem, actually, because if you imagine Spider-Man's kind of cape stuff going on here, more like his face. We've got the red, and then we've got his eyes here. Just going for some doodle time here. All right, so anyway, we do call this one the Spider-Man theorem. Because again, I'm sure 1152 is not a very catchy title. All right. So taking a look at this one, again, you kind of see that Spider-Man image going on here of his, it's more like the Venom look. But anyway, so if we want to find the angle measure inside a circle, in this case AEB, so that's AEB, so that's this one. All right, in order to find that angle measure, we need to take this arc that it intercepts, which is 139, and this arc, and take their average. So we're going to take the measure of arc AB, add it to the measure of arc DC, take all of that and divide by 2, and we'll get our angle measure. So that means that 139 plus 113 is going to be divided by 2, or we're going to get 126. That's this angle measure. Sometimes another version of this problem is to get this angle measure. All right, and so in that case, you would just find the blue angle, but then the red and the blue are a linear pair. So if we know that the blue is 126, subtract that from 180, and we'll get our red one. So that happens a lot as well. All right. The next theorem that we're talking about is 1153. But anyway, so it states that if a tangent and a secant, two tangents or two secants. So notice there are three options here. So tangent and a secant is this guy. Here's your tangent, here's your secant. Two tangents, that's these ones, or two secants, there they are, intersect in the exterior. So the previous one was talking about two secants or chords meeting on the inside. Well, now we're talking about meeting on the outside here. So they have this exterior point. then the measure of the angle formed is half the difference. So instead of sum from the last time, we are now talking about subtracting them. So half the difference of the measures of its intercepted arcs. So the intercepted arcs are a little strange in this one, but AD, for instance, is right here, and that's this arc that they're talking about. Then we have BD, and that arc length is going to be subtracted from the larger one. So a lot of times when I think of this, it's usually the large minus the small. In fact, it always is divided by 2. So you do need to come up with a positive number. So usually start with the larger one. So here we are with our major arc. Notice it's got EHG. So in that case, it is going to be a lot bigger, but then we'll subtract the smaller one of the 2 tangents intersecting, and then divide by 2 and get angle F. And again, this is the angle right here. Looks like they're trying to say the arc there, but it is the angle there. All right, and then the last one again just takes this outer larger arc and subtracts the inner smaller arc. All right. So taking some examples of that, looks like we have one here at the beginning that is 2 chords, and then we have one here that's a tangent in a chord, or a secant if it goes on. All right. So we're going to find the value of x in this case, and x in both of them is this angle at this outer point. So we are talking about that. All right. So again, most of the time and always, it is the larger arc measure minus the smaller arc measure. So here we go with the larger one, and the larger is 87. And then from there, we're going to subtract the smaller arc measure, which is very small, in fact, kind of minuscule to see, and that's 7 degrees. And then once we find that number, we will divide by 2, and that gets us angle X in this case. So angle X is going to be 80 divided by 2, or 40 degrees. Alrighty, same thing happening over here. So now we have 200 degrees as this arc, the larger one. And then from that, we're going to subtract the smaller arc that is formed by these 2 secants or tangents. So 74. And then once we find that difference, we'll divide everything by 2. So 200 minus 74 is 126. Divided by 2 is 63. And again, that's the measure of angle X in this case. All right. Now we have a few more things going on. So these are all angle relationships in a circle. It pretty much just summarizes what we have. So this one here was our first one that we talked about, and that was talking about points that are on a circle that meet. So again here, on the circle, on the circle. This next one here is talking about inside of circles. This is just a summary page. And so again, here's your dot inside. And then we also have the one outside. And so here we are with a dot outside. So depending on if your dot is on, inside, or outside, you're going to use some different ideas. So in summary, if your dot is on a circle, we're talking about it being half the measure of its intercepted arc. All right. Then the next one, if it's inside the circle, here it is, the Spider-Man theorem, then it's half the sum or addition of what's going on. And then if it's outside, it's again half. So lots of halves here, okay? And it's half the difference. Alrighty. So we're going to use each of those in this next example here. So remember that in a lot of our examples, it's not just one set of lines to determine if you're talking about inside or outside. It's kind of a multitude of all of them together in order to find out what's happening. So for instance, let's at least see what we need to find. And we need to find YZ. So YZ is this arc right here. So in order to get this arc right here, there's a lot of ways we can get that. For instance, we could be looking at this angle that's outside and maybe this arc that's intercepted, but that's not going to help because we don't have this intercepted arc, so we might be able to find that. We could also use this arc here in the Spider-Man theorem plus this arc to divide by 2 and get this angle. But basically at this point we want to find as many pieces as we can of the puzzle. So the first thing that I'm going to try here is, nope, that one is that angle. Let's see which piece. We have that one. All right. Just thinking here. No, you haven't lost me. All right, let's see. All right, we are going to start with x v y, x to v to y, and the fact that it is half of uy and wz. Oh, I was reading this differently. So it turns out that 49 is actually this arc here. I thought this was the angle. So misplacement of that degree. Okay, so now that we know that this is 49, we also know that this arc is 68. And so we can, in fact, get both of these angles. All right, excellent setup. So in order to get these central angles of the inside, okay, so remember that that's inside, we're going to do half the sum of those arcs. So we're going to take 68 and 49, add them together, divide by 2, and we'll get these two green angles here. So 68 plus 49 is 117. And then we divide by 2. So 58.5 degrees. So again, that's for x, v, y. And also at the same time, angle WVZ. All right. So now that we know that these two are 58.5, which since we knew this was 113, didn't we already know what that measure was going to be, which is not 58.5? Geez Louise. Okay. So we know that the 180. Oh Lord, that was that angle. Okay. So let's try this again because life happens. Okay. So we're going to try it again on my tiny little note piece of paper. Alrighty, so here it is again. So 49 is the measure right here, so yay, all right. 113 is this measure, and so to get this measure, as I just said in the other piece, we're just going to take 180 minus 113. Okay, so 180 minus 113 is going to get you 67 degrees, and that's going to be this angle measure as well as this angle measure. All right, but then we are going to take the focus off of the entire circle, and now we're actually going to just talk about this arc, this inner circle, and then that arc piece. So taking a step back from the whole picture, we have this chord, and this point is Y, and U, W, and Z. All right, and so if this is 68, this one over here is 67, we can use both of those in order to find out what this arc measure is, or in fact, UY, which is right here. So remember that what you would really do is 68 plus X in the Spider-Man theorem divided by 2 makes 67. So the idea is that you would take the two arcs, 68 and X. Sorry, keep bumping. All right, divide that by 2, and we're going to get 67. So in that case, we need to, well, we could just guess what the average is, but we need to get this digit. So in order to get that, technically we could multiply by 2 to both sides. But really, we're asking what two numbers average to be 67. So this is going to have to be 66. But let's double check with our algebra. So 68 plus X is going to equal 67 times 2, which is 134. And then we'll need to subtract 68 from both sides. And so our X is, in fact, 66. All right. 67, just double checking. Okay. So that means that this now arc measure is 66. I'm going to put that in my original diagram as well. So 66 is right here on this arc. All right, and remember that we are trying to find YZ, which is all the way over here. So maybe I want to double check that we know that. All righty. So in order to, again, to find this arc measure, this goes back to the theory that if we have a point on the outside, we would take the larger arc minus the smaller arc, divide it by 2, and get the angle that's outside. But again, we're going to have to work backwards. So stepping outside of that whole image again, we are just going to be focusing on X being out here, meeting at Y, and Z. And the fact that we are trying to find YZ, so we don't know what this larger arc is, but we do know that this arc right here is 66, and we know that this outer angle was given as 49. So in order to find the missing arc, we would be doing the larger arc minus the smaller arc. Separating our problem here. Divided by 2. And the larger arc we don't know, so let's just call it X. Smaller arc is 66. And all of that is going to be divided by 2 in order to equal 49. So again, taking a number, minus 66, dividing by 2, and we'd get 49. So in order to solve this, just like we did over here, everything's being divided by 2, so let's undo that by multiplying by 2, which means that you have the 2's cancel and left with x minus 66, and that's going to equal 98. Add 66 to 98, and we're going to get an x of 164. So that means that this arc, which of course we're hoping is bigger than 66, is 164 degrees. All right, so that again is the measure of YZ, which is what we were hoping to find. So again, unlike having just one problem where you're using this outer point or one problem where you're finding this inner angle here, we had 2 of them. So 2 problems led to your answer. Also, the fact that it's not just this plus this divided by 2 gets us that. Sometimes you have to work inwards to find what you're looking for. So undoing the order of operations there. All right, so that was 12.5. Sorry about that last example being a little off. So hopefully we have all 3 of those theorems. Again, points that are inside, outside, and on the circle. So find the measures of angles formed by lines that intersect circles, either, again, making a point inside, outside, or on the circle. All righty.